This is a building like no other in the world. It's the pinnacle of modern engineering. It's the tallest building in the world, the Burj Khalifa. This skyscraper perched in the desert is 828 meters high. Total weight over 500,000 tons. The steel he uses alone could circle the Earth a quarter of a time. It is no easy task to raise such a behemoth to the ground. So do you know how this astonishing giant building was built? Let's go inside it today. Disassemble its mysterious structure. Unravel its engineering secrets. See how this skyscraper rises from the ground. This massive building is located in Dubai, United Arab Emirates. This is an incredibly rich country. However, with the development of the economy, the sheikhs of Dubai are not content to be an energy exporter. To get rid of our dependence on the energy economy, they set out to develop tourism in Dubai. So the idea of building the tallest building in the world came into being. After all, who wouldn't want to visit the tallest building in the world? Dubai's location makes it easier for it to attract tourists from both Europe and Asia. He's in the middle of the Middle East, facing the Persian Gulf. There's more than just an inexhaustible supply of oil. And then there's the desert. The Burj Khalifa was designed to weigh more than 500,000 tons, so you need a very strong foundation. But this is very difficult to achieve in a sage environment. The foundation should bear the full weight of the building. If there is no organic salt carrier, subsidence may occur over time. In order to solve the problem that the foundation is not solid enough. And what they did was very clever. They built a huge Fahrenheit foundation for the building. It is 3.6 meters high. A massive concrete block covering an area of 7,432 square meters, same as 28 tennis courts. It sank to 7.3 meters below the surface. At the same time, in order to ensure the stability of the valve plate is fixed by 194 concrete piles. Each root is 1.5 meters in diameter, through the soft ground to a depth of 50 meters. But unlike traditional bollards, they will never touch the hard rock. It uses friction to hold itself in place. And even though any of those struts are stuck in the sand, they cannot withstand the tremendous forces applied to them. But if there are enough, each piece has a certain amount of friction, so that together they can support the tremendous weight of the building. Valve foundation works very well. In the 10 years since the Burj Khalifa was built, the tower sank very little, only between 40–50 mil. Engineers overcome the instability of the desert floor, but wanting to build the tallest building in the world, a solid foundation is not enough. How to build a staircase is also a big problem. One of the big challenges was getting the building materials up to the height they were needed. And as the building gets taller and taller, the concrete required for construction needs to be pumped up to 600 meters in the air. The concrete will take more than half an hour to arrive after being transported in the pipeline. Such a long pumping time can cause the concrete to harden during transportation. It may even clog transportation pipelines, cause the pump to fail. So engineers invented a new type of concrete for the Burj Khalifa. They added various chemical mixtures to the concrete to change its properties. Make sure the concrete has sufficient fluidity and plasticity. It also uses the most powerful pump on Earth, the Kipsmeister. He was able to pump concrete from the base of a building all the way to a height of 600 meters in one go. This also broke the previous pumping record of 492 meters during the construction of the Shanghai World Financial Center Tower. But the tower's unparalleled height again caused a problem. His hexagonal concrete core is too tall. If there are no additional support points, he can't get up. Therefore, the designers built 3-volt arms around the center of the main building for support. Their clever positioning helps disperse the gravity carried by the core columns, spread it all over the foundation. And this design structure is also used for the first time on a skyscraper. In 2007, 3 years after breaking ground, the Burj Khalifa is taller than the Empire State Building. But the taller he is, the more dangerous he is. In addition to solving the structural stress problem of the building itself, it is also necessary to deal with the impact of the external environment on the building, such as storms and lightning. Dubai is located in the Arabian Desert. There are powerful dust storms every summer. Winds can reach over 50 miles per hour. Zhejiang poses a serious threat to the building. In 1940, high winds struck the deck of the Tacoma Suspension Bridge, causing strong shaking, caused the bridge to collapse just a few months after it was built. In 1965, strong winds destroyed 3 cooling towers at a power plant in England. To prevent a similar disaster in Dubai, engineers must do something to overcome the effects of the storm. Most high-rise buildings built after the 20th century, they all use a very basic mechanism to deal with the shaking of buildings. It is to hang a very heavy object from the top floor. Use it to balance any movement of the building. It's called a mass shock absorber. Taipei Wonder One building. The former world record holder for the tallest building used it. In 2015, he protected the building during a 115 km/h typhoon. But installing this mass shock absorber takes up space on the 6th floor of Taipei Wonder One Tower. Engineers don't want the space on the Burj Khalifa to be wasted like this, so they got away with the shock absorbers. They redesigned the shape of the entire building. When you see this tower, you'll notice that this skyscraper is not a traditional shape. Its shape is similar to the desert flower spider orchid. 3 petal-shaped base wider at the same time. It gradually rotates and narrows as the height increases. It's like lots of buildings coming together at different heights. There is no outer wall of the same height as the building. When the wind blows towards the building, he blew against walls of different heights and shapes. So the eddies are different at different altitudes. Compared to facing a powerful fragrant vortex, much better to create some smaller vortices. These vortices cannot contain the building and cause damage to him. As a terrifying storm devastated Dubai, it may also bring lightning strikes. Lightning can contain 100 million volts. Once hit the building, it will cause tremendous damage. To protect the building from lightning, engineers installed the world's most advanced lightning protection system on the top of the tower. The sensors on this lightning rod can predict when lightning will strike the tower and sends out a river of electricity that attracts lightning to the lightning rod. If lightning strikes the top, this provides effective protection. But the Burj Khalifa is too tall. Lightning can't just hit the bottom of the tower. He could hit anywhere in the building. So, the perimeter of the building is protected from lightning strikes. Fortunately, engineers have ingenious designs. He's hidden inside the exterior of the building. The entire metal exoskeleton of the Burj Khalifa resembles a Faraday dragon. It can direct the current generated by lightning to bypass the inside of the building and flow to the ground, to protect the building's electronic devices and visitors from damage. These protective facilities have kept the Burj Khalifa safe for nearly 10 years. Today he has become a global landmark. There had never been a building this tall on Earth before. He is almost twice the height of the Empire State Building. His equal rival, China's Shanghai Tower, is also about 200 meters shorter than him. Now thousands of people come here every night to see the building, watch the fountain and the light show. From an impregnable foundation to a solid concrete core, from his exceptional protective skin to various ingenious design schemes, his perseverance here proves that he is an engineering marvel. It is the best, is the highest, one of the greatest buildings in the world.